Hello everyone, this is Raghavi, Assistant Professor from Department of Computer Science. Today we are going to see about the concept image enhancement using arithmetic and logic operations in digital image processing. Arithmetic and logic operations. These operations are performed on an image in a pixel by pixel basis. That is, these operations are performed between two or more images. A subtraction of two images results in a new image whose pixel coordinates is the difference between the pixels in the same location in the two images being subtracted. When dealing with logic operations on grayscale images, pixel values are processed in a manner as a string of binary numbers. For example, performing the NOT operation on a 8-bit pixel produces a white pixel. Intermediate values are processed in the same way, changing all ones to zeros and vice versa. In the AND and OR operations, image masks light represents a binary 1 and the dark value represents a binary 0. Masking, sometimes also referred to as a region of interest processing. Image subtraction. These operations are also performed between two images in a pixel by pixel manner. Image subtraction or pixel subtraction is a process in which the numeric value of one pixel or a whole image is subtracted from another image. This is done primarily for two reasons. First one is for leveling uneven sections in the image. For example, if an image is containing some shadow or a blurred one, in that case, this image subtraction is done between two images. This helps us to tell that something has changed or moved after performing the operation. This image subtraction technique is particularly used in astrophotography field in order to search for computerized asteroids. The difference between two images expressed as g of x comma y equals to f of x comma y, the first image, minus h of x comma y. The resultant image that we get is g of x comma y. Next comes image averaging. In this, we will consider a noisy image on an input. The resultant image we get is g of x comma y, which is expressed as g of x comma y equals to f of x comma y plus reta of x comma y. The symbol reta indicates the addition of noise to an input image. For every xy pair in the image, the noise is uncorrelated and it has this 0 as an average value. Then it is expressed as g power x of x comma y equals to 1 by k f of x summation I equals to 1 to k ji of x comma y. The objective of this technique is to reduce the noise content by adding a set of noisy images. Let us say the arithmetic and logic operations using a MATLAB. Let us see the example for arithmetic operations. There are three images A, B and C. In this we are going to perform addition, subtraction, multiplication and division. First I am getting an image cameraman. Next arise.png image. Finally I am creating an image with a background black and thus with a small square inside it. To add, subtract, multiply and divide, there are predefined functions in MATLAB. Such for adding, imadd is the function to be used. For subtraction, you need to use msubtract, and for multiplication we need to use multiply, And for division, we need to use the function mdivide. All the images I have displayed it using subplot. Subplot means here 5, 3 and 1. These values represents first value represents the number of rows, second value represents the number of columns, and the third value represents the position where you want to display. In this I have created a 5 rows, 3 columns, and in the first column I have to display the input image, that is the original image. Similarly, the next image rise, I have to display it in the position second column. Similarly, the third image I have to display it in the third column. Let us see the output. This is the output which we get after running the program. Image A, B and C, there are 3 images performing additional operations. First A and C, B and C, A and B. Next performing a difference, A and C, B and C, A and B. Performing multiplication, A and C, B and C, A and B. When performing division, we will getting the following output. Next, the logical operations. The same way, we are reading 3 images, we are performing AND operation, OR operation, NOT, XOR. For AND, we need to use a function bit AND. For OR, we need to use the function bit OR. And for XOR, we are using a function bit XOR. And for a NOT, we are using bit compare. CMP indicates compare. Let us run this program. This is the output we get when performing a logical operations on a 3 images. When performing AND operations on A and C, B and C and A and B, performing OR operations on A and C, B or C, A and B, and performing XOR operation on A and C, B and C, A and B, performing NOT operation on A, B and C. Thank you for watching.